Right, in section 6.8, we're solving radical equations. So in order to do that, you just need to first isolate the radical. Second, raise both sides of the equation to the power equal to the index of the radical. The last thing you'll do is simplify and solve. So you're always going to want to identify what your index is before you, so that you can raise it to the appropriate power. So let's look at number 1. It says the cube root of x minus 2. So if I want to solve that, first I'm going to isolate the radical by adding 2 to both sides. So I add 2 to both sides. This is the cube root of x equals 2. So my index here is 3. So I'm going to raise both sides of the equation to the third power. Remember, just like when we solve equations, whatever you do one side, you got to do the other. So if I raise the left side here to the third power, then I got to raise the right side to the third power. These powers of 3 cancel off. So this is going to get rid of your root. So this becomes x equals 2 cubed, and 2 cubed is 8. So x equals 8. Example number 2. This one says 5 times the cube root of 4x plus 3 equals 15. So again, if I want to solve that, you need to isolate the radical. So first I see this multiplication here, so I'm going to undo that multiplication by dividing by 5. So those 5s go away. Again, this is solving equations, so whatever I do to one side, I do to the other. So this is the cube root of 4x plus 3 equals 15 divided by 3, 15 divided by 5, which is 3. Last part, identify the index. The index here is 3. So I'm going to raise both of these to the third power. So this will get rid of your radical and your exponent. So whatever was underneath the radical is going to just be copied down outside of the radical. So this is 4x plus 3 equals, and 3 cubed is 27. Subtract 3 from both sides. So this is 4x equals 24. And certainly you can do 24 divided by 4. And you would get 4x, so I'm just going to move it up here. 4x equals 24 divided by 4, so x is 6. And certainly you could go back and plug this in and just verify with a calculator. So if I want, I could verify this. So I'd write 5 cube root. So this one's a little different. So this is going to be the cube root of 4 times 6 plus 3. And I get 15. So you can always double check your answers. Number 3, now you have radicals on both sides of the equation. So what you do in that case, you just raise both sides of the equation to the power of your index. So here my index is 2, so I'm going to raise both of my sides of my equation to the power of 2. So squaring the left side is going to leave me with 35x. Squaring the right side is going to leave me with 5 squared times the square root of x plus 2 squared. So I'm breaking it apart. I'm just distributing the exponent to each of those two things, to the 5 and to the square root. So this is going to leave me with 35x equals 5 squared is 25. A square and a square root get rid of each other. So this is 25 times x plus 2. To solve this, distribute the 25 to the x and the 2. So this is 25x plus 50 equals 35x. Solve this one for x. We could subtract 25x from both sides. So this is 10x equals 50. Divide both sides by 10. So x equals 5. Next one is 3x to the 1/5 power. So 3x minus 1 to the 1/5 power equals 2. So here they give you as a rational exponent. So we just want to make that into a root. So this would be the 5th root of 3x minus 1 to the 1st power. So we can just leave it like that. That equals 2. Identify your index. Index is 5. So raise both sides to the 5th power. That gets rid of the root and the exponent. So this is going to become 3x minus 1 equals 2 to the 5th power. And 2 to the 5th power is 32. This is 3x minus 1 equals 32. Solve this by adding 1 to both sides. So 3x equals 33. Divide both sides by 3. So you get x equals 11. And again, if you wanted to, you could go and you could plug this into your calculator. So let's zoom out a little bit so you can see all that. So you could plug this into your calculator. So this is 3 times, we found x to be 11. 3 times 11 minus 1 raised to the 1/5 power. And that gives you 2. So you can always double check your answer by plugging it in to your equation. If you have any questions about solving radical equations, please write those questions down and bring them with you so you can get them answered in class.